Hello, today's video is going to be talking about how to graph an absolute value function. So the big key points that we're going to focus on is that we're going to graph the absolute value equations. We're going to write the equation of an absolute value function. So if we're given the graph, and we write the equation. And finally, we need to make sure we can describe what kind of transformations have taken place to said graph. So the first thing we're going to start with is, well, what about the absolute value parent function in the first place? Well, the equation is we have the absolute value parent function. The parent function is just y is equal to the absolute value of x. It's the easiest question that we could possibly have that involves an absolute value. Now, when we go to graph it, I'm going to start by just kind of making a short little table. So if I've got an xy table, if I use -3 for x, I know the absolute value rule says if it's negative, we need to change it to a positive. So I'm going to change -3 to +3. If x is -2, I would change that to +2. If x is -1, I would change it to +1. But when I get to 0, the absolute value is 0. It's not negative. It's got to stay the same. Same with 1. If we have a +1, it's going to stay positive. 2 would stay +2. 3 would stay +3. So on and so forth. So our graph is going to look a little like this, where it's going to look very much like a V. And what this is going to do is it's going to have a couple of special points. First of all, this point right here in the middle at the origin. This point at the origin is what we call the vertex. Now, part of what we're going to be doing is going to be moving the vertex left, right, up, and down. So the vertex is right in the middle. It's going to be the point where the graph changes direction. And it's also going to be in reference to a second part, which is the axis of symmetry. The axis of symmetry is going to cut our graph into two congruent sides. So when we say congruent, that means it's going to be the same thing on either side. It's going to be basically a reflection. So remember, when we talked about transformations in the first marking period, we have the same letters at the same positions. So in regards to A is going to be found directly in front of the absolute value. If A is more than 1, we would call that a stretch. If A is between 0 and 1, we would call that a shrink. And if we see that A is negative, first of all, A is negative, has no bearing on either a stretch or a shrink. The negative by itself is what we call a reflection. Now C, the same as what it did in the last unit. C is going to do the opposite of what we typically think it would do. So if we see -C, that tells us it's going to the right. If we see left C, that means it's going to the left. The last item is if we have a plus or a minus outside of the absolute value, that's going to be the D value. So if we see plus D, that's going to mean it's going up D units. If we see minus D, that means all the points are going down D units. Okay, so in regards to basic steps on graphing an absolute value, the very first thing is you need to find the coordinate of CD. You always have to find your coordinate of C, D. Now, one thing to pay attention to is in the formula, it's a negative. In the ordered pair, it's a positive. So that means we're going to change the sign. If it was plus C, we would change it to -C in the ordered pair. So after we find the vertex, what we're going to do is we're going to use slope. A is going to be very similar to slope, but it's going to be either both going up or both going down. So let's say we have the equation, the absolute value of x plus 2 minus 3. The first thing that we would want to find is we'd want to find our vertex. Our vertex, we said, is going to be CD. In this case, we have C would be -2 and D would be -3. So the first thing I'm going to do is on my graph, I'm going to find the point 2, -3. The next thing I would need to find is my A value. My A value, again, is the number that would be directly in front of the absolute value. In this case, there's no number there, which if you remember to graphing linear functions, that's going to default to pretty much a 1. So our slope of 1, I'm going to turn that into a fraction. That would be 1 over 1. So I go up 1 over 1, and this would allow me to plot all the points going up and to the right. However, I need the graph to look like a V, so it looks like the absolute value is supposed to do. So instead of what I'm going to do is I'm going to go up 1, left 1, up 1, left 1, up 1, and left 1, over and over and over. And that's how we do a graph for an absolute value. So second equation, we have negative absolute value of x minus 1 plus 2. So we need to find our vertex. Our vertex in this case, we have to switch the sign of c, so that'd be positive 1, positive 2. So I'm going to start by putting my vertex on my graph at 1, 2. The second thing I need to do is I need to find my slope, in this case a. There's no number here, there's just a negative, so we're going to treat that as a negative 1 over 1. So from my vertex, I'm going to go down 1, right 1, down 1, right 1, over and over and over. And that will give me half of my graph. The other half I'm going to find by going down 1, over 1 in the opposite direction this time. Down 1, over 1, down 1, over 1, down 1, over 1, over and over and over again, until I can connect my dots and make an upside down V in this case. Now, if I was trying to describe the transformations on this graph, the transformations, we would just look at the different terms that we have. So the first transformation I see is, well, this one went down instead of up. It has a negative A value, so that's going to tell us it's a reflection. The second transformation that I see is, well, I see minus 1. At the beginning, we said if we had x minus c, that meant going to the right. So this is going to be right, in this case, 1 unit. Our final term, d, we said if it's plus d, that means we need to say up whatever d is, in this case 2. And so we've got 3 transformations here. We have a reflection, right 1, and up 2. Okay, our next equation, we have 4 absolute value of x plus 1 minus 3. So I'm going to do the same thing here that I did on the last one. I need to start by finding my vertex. My vertex, positive 1 switches to negative 1, negative 3 stays the same. After I do that, I'm going to find my A value, in this case 4. I'm going to make that 4 over 1. So the way I'm going to apply my slope is I'm going, from my starting point, my vertex, I'm going to go up 4 spaces, right 1, up 4 spaces, right 1, and then I connect the dots. Now I would do the same thing going to the left this time, so I'm going to go up 4 spaces to the left 1, up 4 spaces to the left 1, connect the dots. Now when I'm talking about the transformations on this graph, this one's going to be pretty straightforward too. We say our A value is 4, and when A is greater than 1, that tells us it's a stretch. So this would be a stretch of 4. In regards to our C value, we see that the equation has x plus c, or x plus 1. And like we had discussed, plus c means it's going to go to the left, whatever c is, and so in this case it's going to go left 1 space. Our final item is that we have minus 3 at the tail end, so we know if it's minus d, that means it's going to go down d units, so down 3 units in this case. Okay, so this is going to be the final graph on the video. So again, we're going to start by finding our vertex. Our vertex in this case would be at CD, which we can see, we'll see it's got to switch signs, that would become positive 1, and we'd have positive 5. our a value in this case is -2, or -2/1. So that's going to tell me I'm going to start at the coordinate 1, 5, and my slope is -2/1. I would do the same thing going down and to the left, which gives us a graph that looks like that. Now, we have a couple of transformations here. The first transformation is, well, I see it's going down instead of up, so I know this has been reflected. The second transformation I see here is, well, I've got an a value of 2. That's going to be steeper than original, so this is a stretch of 2. I know my starting position. I have x minus c, so x minus 1 is going to tell us we're going right 1 space. And when I see plus 5 at the end, plus 5 is going to tell us we're going up 5. And so those would be the 4 statements here, which have been reflected with a stretch of 2, right 1, and up 5. So how do we write the equation of an absolute value? Well, I mean, the first thing that we would want to do is we're going to find our vertex. This is a starting thing. So I see my vertex here is at -2, -3. The next thing I need is I need my slope. In this case, I can see I'm going up 1, 2, 3, 4 over 1. So there's our a value. So when I go to write my equation, I have y is equal to our a value, which is 4, absolute value of x, and since it's -2, we have x minus -2 would be plus 2, and then minus 3. And it's really just about filling in the blanks. The biggest thing to just kind of remember is the x should flip signs. Okay, so this is the final question on the video. We have, what is the equation of this absolute value function? Same as last time, we need to start by finding our vertex. We can see our vertex is at 1, 2, 3, 4. It's 1, 2, 3, 4, 5. It's at 4, 5. So there's our CD. Second thing we need to know is what is our slope. So from our first point here, I see I go down 1, right 2. So a is equal to -1/2. So this would tell us our equation is y is equal to a, which is -1/2. We have x minus c, or in this case x minus 4, plus 5. And that's all we have to do. Thank you for watching, and make sure you complete your assignment.